Kubernetes cluster on our machine with the latest Kubernetes version 1.22. And now we can check the status of the cluster using minikube status command. And we see that all the components inside are running and everything is configured, and now start to actually interact with our cluster using kubectl command line tool. And kubectl actually gets installed as a dependency when we install minikube, which you see right here, installing dependencies for minikube, and Kubernetes CLI is actually kubectl. And that means we already have that available. We don't have to install it. So now I can do kubectl get node, and this will display all the nodes in the cluster. In our case, we just have one node, which is control plane and the worker node at the same time. And we see information for each node, like the status, the Kubernetes version that it's running, as well as when it was added to the cluster. So with this, we now have an actual Kubernetes cluster running locally on our machine, and we can start deploying applications in it. So from this point on, we're going to be interacting with the minikube cluster using kubectl command line tool. So minikube is basically just for the startup and for deleting the cluster, but everything else configuring, we're going to be doing through kubectl. Now we have enough knowledge to deploy a very simple but realistic application setup in a Kubernetes cluster. We will deploy a MongoDB database and a web application which will connect to the MongoDB database using external configuration data from config map and the secret. And finally, we will make our web application accessible externally from the browser. So let's get right in. So I have two resources here. We're going to reference the Kubernetes documentation to create our components, which is a realistic way of working with Kubernetes, and also a Docker Hub where I have the web application image that I created, which is publicly accessible, so you can also pull it directly from the Docker Hub in your Kubernetes cluster. So first, let's go ahead and create all the Kubernetes configuration files that we need for deploying our application setup. And for that, I'm going to go to Visual Studio Code, where I have a Kubernetes demo folder open. And in this folder, we're going to create 4 Kubernetes configurations files that we need. We're going to create a config map with MongoDB database endpoint. We're going to create a secret with username and password for MongoDB. And then we're going to create a configuration file for deploying a MongoDB application and its service. And then we're going to create a Kubernetes configuration file for deploying our simple demo app application with its service.
Почувствуйте разницу при работе с множеством баз данных. DataGrip – мощный кроссплатформенный инструмент.
So the first file will be called running inside the container. in config map first file will be called mongo-config.yaml. And creating a config map in Kubernetes is super simple. For the syntax, we can reference the Kubernetes documentation. So I'm going to copy the first part here, paste it. So I'm going to copy the first part here, paste it in, and that's basically the main syntax we're starting from. Let's call our config map mongo config. So we have the metadata, and then we have the actual contents of this config map. Within the data attribute, we have all the key value pairs that we define as external configuration within this config map. In our case, we just have one, which we're going to call mongo URL as a key. And of course, we need a value for the MongoDB URL. And the value will be the service that we're going to create for MongoDB application. And we're going to call that service Mongo service. And in a couple of minutes, you're going to see how to create this Mongo service. And that will be basically all the configuration we need for creating config map. So that one is done. Let's now go ahead and create mongo secret.yaml, which will hold the username and password for MongoDB application. Again, to reference documentation, I'm going to take this one and let's actually copy the whole thing. So we have the secret kind instead of config map. Let's call this mongo secret. We have type opaque, which is the generic type for defining secret data, basically. And we have the same data attribute here. And let's actually create our own values. Let's call this Mongo user and Mongo password. And as you already learned, the values in secret are base64 encoded. So we can't just set the values plain text. We have to encode them first. And encoding values is super easy. We're just going to do echo. And let's call it Mongo user and base64 encoded. And the same way, let's do Mongo password and paste those values. And this will be our secret configuration. And now, when we create deployments for our applications, we can reference any of the values defined in the secret or config map. So let's see how that works. Again, let's create a new file and let's call this mongo.yaml. This is going to be a configuration file where we're going to create deployment and service for MongoDB. You can have separate files for them, but it's a very common thing to put them together because all the deployments need services. So you have them grouped in one YAML file. And again, let's reference the documentation for the deployment example syntax, and we can then adjust the values as we need. And as you see, deployment configuration file looks a little bit more complex than config. As you see, deployment And we can then adjust the values as we need. And as you see, deployment configuration file looks a little bit more complex than config map or a secret. So let's go through the configuration and understand all these attributes. So we have the metadata section and the specification. And these are basically deployment specific configuration that we have in the specification section. And let's start with the main part of the deployment, which defines the blueprint for the pods. And that blueprint is defined as a template. So template basically is a configuration of the pod within the configuration of deployment. And you see that template section has its own metadata and own spec or specification, just like deployment has its metadata and specification, right? So this part actually configures the pod within a deployment. And in the specification of the pod, we have the definition of containers. So this is a list of containers. As you learned, you can have multiple containers in a pod, but mostly one main application per pod. And this is where we define which image will be used to create this pod. In our case, this is going to be a MongoDB image. And if we search for Mongo in Docker Hub, that's basically the image name. And you can find all the tags in the text section. And we're going to use the tag 5.0. In the text section, and we're going to use the tag 5.0. So Mongo 5.0. In the text section, and we're going to use the tag 5.0. So Mongo 5.0. That's where we define the image of the container within the pod. We can name this MongoDB. This is just the name of the container. And we also have the port where the container will listen. And let's check our image. And as you see, MongoDB starts at this port, so we can just copy it and paste it in here. So this basically just configures our deployment to create pods with a MongoDB image version 5.0. So that's the core of a deployment. Now let's see what is all this other stuff here. First of all, we have this labels attribute in the metadata section. And then we also have match labels attribute. So what is this about? In Kubernetes, you can give any component a key value pair labels. So you can label anything from pod to deployment to config map, etc. And labels basically are additional identifiers of the components in addition to the name, for example. So you can identify and address specific components using their labels. Now, why do we need them? First of all, when we have multiple replicas of the same pod, each pod will get a unique name. However, they can share the same label. So we can identify all the pod replicas of the same application using a specific label that all of them share. And that's why in the metadata of the pod, we always have this label. So for pods, labels is a required field. For other components like deployment, config map, etc., labels is optional, but it is a good practice to set them. Now, when we create pod replicas, how does deployment know which pods actually belong to it? Or how does Kubernetes know which pods belong to which deployments? And that is defined using this part right here. So selector match labels is in the specification of the deployment, as you see. And this defines that all the pods that match this label belong to this deployment. So that's why we have match labels here. So this selector will match the pods created with this configuration because they have label app nginx. Now, are these labels given or can you select any key value pairs? Well, these are totally up to you. You can call it whatever you want. You can call it my key, my value. It doesn't really matter. However, the standard and a common practice in Kubernetes is to use app key in the labels when labeling your applications. And the value will obviously be whatever application you have. So let's actually change and set the values to Mongo instead of nginx, because that's our application. And of course, we want to match label app Mongo. And let's also change this one right here to Mongo deployment. And finally, last attribute we have here is replicas, which is super simple and straightforward. This just defines how many pods you want to create using this blueprint. In our case, let's do just one replica because it's a database. And as you learned, if you want to scale databases in Kubernetes, you should use stateful set and not a deployment. To keep everything simple, we're going to stick to one replica. And that basically configures our MongoDB deployment and the pod blueprint. Now let's add a service configuration because every application needs a service in Kubernetes, and that's going to be a separate YAML unit or YAML section, and we're going to separate it using 3 dashes, which is basic YAML syntax, nothing specific to Kubernetes. And again, let's grab a service example. and adjust it as we need. Now, service configuration is much again unit or YAML section, and we're going to separate it using 3 dashes, which is basic YAML state as we need. Now, service configuration is much easier than the deployment, as you see. First, let's change the name. Let's call it Mongo Service. And remember, this is the endpoint which we will use to access Mongo, and that's what we defined right here. So this is the name of the service. And in the specification, we have service-specific attributes. First of all, we have the selector attribute, which you already know from here. Now, why do we need a selector in service? Because, as you know, service needs to forward the request that it gets to its endpoint pods. How does service know which pods belong to it and which ones it should forward the requests to? Well, using the same label selector as we saw on deployment. So this should match the label of the pods that will belong to the service, which is app Mongo. And that's how service and pods will find each other. And then we have the ports configuration, which is also super simple. Service is accessible within the cluster using its own IP address and the port, and we define its port right here. And this can be any port that we decide on. This could be 80, 8080, doesn't really matter. And we have the target port, which is the port of the pods that belong to the service. And logically enough, the target port should always be the same as the container port, because that's where the application in the pod is accessible. Now that's where the service should forward the request to. So again, very important, port attribute sets the port of the service, and target port tells service to which port it should forward the request to the pods. And this should be same as the container port. Port and target port values can be different, or again, it's a common standard to select the same port for the service as well, just to keep things simple. So let's save this, and that's our configuration for MongoDB deployment and service.
This is your brain when you're struggling to focus. And this is your brain when you're in the zone.
Now I'm going to copy this whole thing and create a deployment and service for web application for our Kubernetes demo application. And let's call this web app.yaml. Paste everything in, and we can just adjust all these values. All these, paste everything in, and we can paste everything in, and we can just a deployment and service for web application for our Kubernetes demo application. And let's call this web app.yaml. Paste everything in, and we can just adjust all these values. in the service and deployment, all the labels and label selectors, of course. And right here, we of course need the correct image of our web application. Going back to our Docker Hub, this is the name of my image. And again, this is publicly accessible, so you can use it as well. And this is publicly accessible. This is the name of my image. And again, this is publicly accessible, so you can use it as well. And the tag is v1.0. And there you go. So this is a very simple Node.js application which starts on port 3000. So that's why we need to define container port on 3000. And container port is same as target port on the service, and we can set the service port to the same value, and this will configure deployment and service for our web application. So this is the basic configuration for deployment and service for any application in Kubernetes cluster. But we have one more thing to configure in our deployment components for both Mongo and web app, which is we need to pass the data defined in the config and secret components. First of all, when starting a MongoDB application, we need to set username and password. So when MongoDB application starts, it will automatically generate a username and password for MongoDB, and we can then use that to access it in our cluster. Now, how do we know how username and password can be configured in a MongoDB on startup? Well, we go to the image documentation, and right here we see the environment variable names for username and password. And these are actually required fields in most of the databases. We have to set them, otherwise we won't be able to access them. So the next question is, how do we configure environment variables in a container configuration? So how do we pass environment variables to this application running inside the container? Well, that's also very easy. We have env attribute for that, which is a list of environment variables with names and values. That's it. So very simple. So name is the environment variable name and value is the environment variable value. So let's copy the name. So this is the environment variable name that MongoDB expects, and we have to set a value, whatever we want the username to be. Now we can directly set the username right here, like this, or in our case, we're gonna reference them from secret and config components. How do we do that? Also pretty simple. We do value from, and we want to reference it from the secret. So we do secret key ref, and under that we have the name of the secret, which we called Mongo secret, and the key, which is Mongo user. So Kubernetes will basically find a secret with this name and get the value set for this key and substitute it as a value for this environment variable. And the same way we're gonna configure the password. So let's take the password, that's the name of the environment variable, same. Secret component, this time with a different key. And that's it. So our MongoDB configuration file is complete. And when it starts, a user with these credentials will be created.
Companies of all sizes use BigQuery to uncover new insights from their data, like cost savings, operational efficiencies, and new ways to grow revenue. BigQuery.
When our web application starts, it will need to connect to the database. So we need to give this web application information about the database endpoint, where can it access the database, and which username and password to use to authenticate with the database. And I have already configured this application inside to expect all these values as environment variables with specific names. So we're gonna pass these three pieces of data as environment variables to the web app application. So let's do that. Again, the name of the environment variable, the first one I actually called username. And we can actually copy the same configuration and paste it here. And you already see an advantage of using configuration from secret or config, because if you need the same information in 10 different applications, you create it once and reference it 10 times. The second environment variable is for password, and I called this one user pwd. And finally, our application needs the database endpoint, which will be db URL. And this value is not in the secret, but in config map. And how do we access value from config map? Very similar as the secret, so we have the same value from. And instead of secret key ref, we have config map key ref or key reference. And then we have name, which we called Mongo config, and key, which is the name of the key. And that's it. So we don't have any of the configuration values hard-coded in our Kubernetes configuration files. We only have references, which makes our configuration way cleaner. So if something changes or the values change here, we don't have to adjust anything in our deployments. So connectivity with the database is configured, and there is one last thing missing in our web application configuration before we deploy all of this, which is making it accessible from the browser. We want to be able to type in some URL and access our web application from the browser, right? And as you learned, we have external services for that. So we will need to adjust the service configuration a little bit. Right now, these service configurations, both of them, are internal services. So to make it external, all we need to do is set a type, which is by default cluster IP. So that's the default type if we don't specify the type, but we're going to set it to node port. So node port is an external service type, and it requires a third port, which is called a node port. So what is a node port? This is a port which will open on the Kubernetes nodes on which the application will be accessible. So on the node IP address and node port combination, we will be able to access this service, which will then access the pods behind it. And node port range is actually defined in Kubernetes, so we can't just type anything we want here like this. It has to be within the range of 30,000 and 32,767. So anything within this range is fine as a value. So we can do 30,000 or 30,100, doesn't really matter. So let's set this as a value, and this completes the web app configuration file. Now we have a very simple but also pretty realistic configuration for deploying an application with its database with external configuration in the cluster. So as a final step, we're just going to create all these components one by one in Kubernetes. So I'm going to open a terminal, and we already have a Minikube cluster running, but there are no components inside. So first, we need to create the external configurations because they need to be there when we create MongoDB and web application deployments.
World of Sea Battle is a boundless ocean where a captain may carve his own destiny.
Because they reference those configurations. So let's create Mongo config and secret first. To do that, we have a kubectl apply command with -. F, which stands for file, which takes a Kubernetes configuration file as an input, like this, and creates whatever is defined inside. And as you see, Mongo config was created. Now let's create Mongo secret. Next, we're going to create a database because our web application depends on it. So it should start first. And again, let's do kubectl apply. With mongo.yaml as an input. And as you see, deployment and service were created. And finally, let's deploy our web application. And there you go. So everything seems fine, but of course, we want to check all the pods and all the components that were created in the cluster. So for that, I'm going to actually switch to command line so that we can see it better. And first, we're going to do kubectl get all, which gives you all the components created in the cluster, which includes deployments, the pods behind the deployment, and all the services. And as you see, we have Mongo deployment and web app deployment pods, each one with one replica running. And we have the services for MongoDB and web app. And web app service is of node port type, which means we can access it externally. However, we don't see config map and secret here. We can get them using kubectl get config map and kubectl get secret commands. So as you see, displaying any component is pretty easy. Using kubectl, you just do kubectl get and the name of the component, like pod, and you get pretty easy. Using kubectl, you just do kubectl get and the name of the component. Like pod, and you get a list of those components with some additional data. And kubectl is actually a very powerful tool, and it has a bunch of subcommands. So as a natural documentation for kubectl, to basically have an overview and see what you can do with it, you can always use kubectl help as a documentation, which lists all the subcommands you can use with it, one of them which we already used, get, and for each subcommand, always use kubectl help as a documentation, which lists all the subcommands you can use with it, one of them which we already used, get, and for each subcommand, like kubectl get, you can also get some help and basically see all the examples plus all the available options. So you can navigate all the options you have. Please see all the examples plus all the available options. So you can navigate all the options you have here. So kubectl get is obviously the most common command you're going to use to list all the components. If you want to see more details about a certain component, you can use kubectl describe command for it, the name of the component, like a service, for example, and the actual instance of that component, like web app service. And this will give you more detailed output about that specific component. Same way you can also do kubectl describe. This will give you more detailed output about that specific component. Same way you can also do kubectl describe pod and then name of the pod, like this. one, and this will give you details about your pod, including the state, name of the pod, like this one, and this will give you details about your pod, including the status of how the pod was scheduled, the container configuration, labels, etc. And finally, of course, when you have applications running in your cluster, you want to check the logs to troubleshoot, debug, or just make sure that everything is fine within the pod. And you can do that very easily using kubectl logs command and just specifying name of the pod like this. This gives you logs of the container inside, and you can even stream the logs using -f option. So as a final step, we want to validate that our application is also accessible from the browser. And for that, we actually configure the service. And we can actually get the service using service or svc command. So how do we access this service? From the browser, because this is a port we're going to use to access it, but which IP address is it accessible at? Well, the node port service is always accessible at the IP address of the cluster node. So all the worker nodes that the cluster has. In our case, we just have one, which is the minikube. So we need the IP address of the minikube. To get that, we just do minikube IP, or using Kubernetes, we can also get node, which gives you minikube and a wide output or a longer output than what you see here, which will give you the IP address of the node, which is the same as this one right here. And by the way, you can use the all wide option for any other get command for services, pods, etc. to get some additional information like this. So let's grab the minikube IP address and access the application at this port, which is 30,100. And there you go. This is our web application. Which is 30,100. Port, which is 30,100. And there you go. This is our web application, which is connected to MongoDB. And we can also validate that by editing something. and saving, because this request goes to the database. And if we refresh, the changes should still be there. Awesome. So we deployed an application with its database in Kubernetes, which is a blueprint configuration for most common application